Hi, it's Mr. Vice with your Unit 5, Lesson 3, Classwork Answer video. So for today, we were talking about standard, which was 8FA1, which is understand that a function is a rule that assigns each input exactly one output. Objective, I know that a function is a rule with exactly one output for each allowable input. And so for our warm-up today, we're going to be solving solve the following system of equations by substitution. So we're going to have so we have y minus 7x is equal to 10, and then our second equation is y equals negative 4x minus 23. So since this y is solved for, we're going to plug in this y here and solve for x there. So negative 4x minus 23 equals 10. Add 23 to both sides. Negative 4x is equal to 33. Oh, I forgot the 7x. Let me plug that in. See, that's a common mistake. So we're going to have negatives. So y gets replaced. We're going to have y minus 23 minus 7x equals 10. Combine like terms for these two. So negative 11x minus 23 equals 10 plus 23 on both sides. You're going to have negative 11 equals 33. Divide by 11 on both sides, and you get negative 3. So let's write that down. So we're going to have substitute the y for negative 4x minus 23 minus 7x equals 10. You're going to combine like terms. You get 11x minus 23 equals 10. Add the 23 on both sides. You're going to get 11x equals negative 33, positive 33. And then you're going to get divide by negative 11. So you get x equals negative 3. So that would be it. And then for this one, we're going to highlight a table that is not a function. And then we're going to write why is your highlight table not a function? So where we have functions, you can see a function is a rule that assigns each input exactly one output. So each input has to have exactly one output. So if we look here, we can see the inputs are negative 1, 0, 1, 2, 3, and they all have unique outputs. But over here, you see it's 0, 2, 1, 5, 2, 8, 3, 11, 0, 12. You can see that the X input 0 has two outputs, 2 and 12. So this one would not be a function because not every input has one output. And you can write that. So the input 0 goes to two different outputs, 2 and 12. So there you go. So 3.1, equations for functions, part 2. Complete the table based on the linear equation. So here, we're going to replace, so this really means that y is equal to 2x, right? So we're going to replace the x with the input that we're looking for to find the y. So y is equal to 2x, and that x is negative 2, and y is going to be negative 4. 2 times negative 2 would be negative 4. So we don't write all this, though. We just put it as negative 4, right? So for the next one, y is equal to 2 times negative 1. So y is equal to negative 2. And then, so because y equals 2x, right? Y is equal to 2x. And then we're replacing the input with the input that's there written to find the rest of them, right? And this ones, you could use different numbers if you want to. I'm just using these numbers because these are the ones I decided to use. So y is equal to 2 times 1, y equals 2. So this one just multiply by 2, right? Take your input, multiply by 2. So it's going to be 2, this one will be 4. Okay. So now this one says take your input and subtract 5. So 5 minus 4 would be -1. 6 minus 5 would be 1. 0 minus 5 would be -5. -8 minus 5 would be -13. Okay. So now this one over here says you take your input and you multiply it by -5. So -3 times -5 would be +15. -2 times -5 would be 10. 2 times -10 would be 2 times 2 times -5 -10. And then 3 times um, -5 would be -15. So this one's getting a little more difficult. And then, so this one over here, y equals 4x minus 5. So this one says that you take your input, you multiply it by 4, subtract 5. So for y is equal to not x equals 9, we can do 4 times -9 minus 5. So y is equal to -36 minus 5, or y equals -41, right? So this one, we put 4. 4 times 4 is 16. 16 minus 5 would be 11. Over here, 4 times -15 is -60. -60 minus 5 would be -65. And then for the 2, plug in 2 here. 2 times 4 is 8, minus 5 would be 3. Okay. We're almost done with the tables. So here we're gonna take the x and multiply it by -3. So we're gonna take the x, multiply by -3, and subtract 4. So for the first one, it's gonna look like -3 times -8 minus 4. So it'd be -8 would be -8 times -3 would be 24. 24 minus 4 would be 20. -3 times 4 is -12. 12 minus 4 would be 8. 3 times -3 is 9. 9 minus 4 is 5. Oh no, this one's not 8 because that'd be 12. Oh, that's right. 3 times would be, no, you add them together. So 3 times 3, -9. That'll be -13. 2 times -3 would be -6. Minus 4 would be -10. So for our last table, we're going to have, we take our x, we take half of it, and then we add 6. So half of 10 is 5, add 6, 11. Half of -2 would be -1, plus 5 would be 5. Half of 4 is 2, plus 2 is 8. Half of -6, -3, -3 plus 6 is 3. Okay. Okay, and that will be it for this section. Going on to the next section. So for this, for the first 3.2, you're going to be just doing a notice and wonder. So you're going to write at least 2 notices here. I notice, and then at least 2 of them there. I wonder. Okay, those would be, that's how you do this section. And once you have 2 of these, you go on to the next section. Okay, so for the last part, 3.3, running around a track. We have Karen was running around the track. The graph shows the time y he took to run various distances x. So here the x-axis is time, and the y-axis, and no, not the x. The y-axis is time, and the x-axis is distance. And so you can see there's a table here from this graph to help you guys kind of answer the question about, is this a function? You can see as he runs various times, his time is given there. So like for 3, it's 1 second, 6 is 2, 9 is 3.2, and so on. So how long did it take Karen to run 6 meters? Well, it'd be 2 seconds. See right here, 6 meters, 2 seconds. How far has he gone after 6 seconds? So look for 6 seconds, which is the y, and it's going to be 18. So 18 meters. So estimate how Estimate when he had run 19.5 meters, so look for 19.5 on the X, because that's the meters. So you can see there is no value for that, so it'll be 18 and 21. So that's between 6 and 6.9. Let's say 6.5 seconds, because estimates. Estimate how far he ran in 4 seconds, so it's going to be, you can see 4 seconds is right here, and he ran 12 to 15, so that would be, um, that would be, let's say 4 seconds. 13 meters. Okay. Now, the next question, does the table and graph represent a function? So, since x is meters, you don't see the meters repeat, and so there's no, so for every input, there would be one output. So you would say yes. For every input, there is one output. Okay. So number 2, Priya is running around the track. The graph shows her time given how far she is from her starting point. So here's a little, is the dose wonder. You guys should have noticed that the graph is not curved. It's curved, it's not straight, and it double backs on itself. So what does that look like? It looks like you see that there's multiple of the same inputs here. You can see there's 50, 90, 200, 150 appears twice, 100 appears twice, and so on, right? So now let's answer some questions. What is the farthest distance from a starting point? Well, let's look for the farthest distance would be 200, right? How long take it to run around the track? Well, let's see. So since this is like one half, this is the other half, it'd be 75 seconds. How long did it take it to run 100 meters from the starting point? Let's see, 100 meters. So there's 200 meters. So 18 seconds and 54 seconds. How long did it take it to run 50 meters from the starting point? Let's see. So there's 250s. So it'd be 9 and 68. Does the table and graph represent a function? Does the table and graph represent a function? Let's think about that. So no, because not every input has one output. You can see like 50 has 2 outputs, 100 has 2 outputs, 150 has 2 outputs, and so on. Okay, guys, so that leaves a summary. Make sure you read that, you annotate it, you uh, do that sort of thing for that summary. And I'll see you guys in class. Bye.